All right, welcome back, everybody. So again, we have one more problem to do out of section 3.9. So let's get to it. Now, I kind of skipped past this slide for time's sake yesterday, but I kind of like to talk through it again today, just as a good refresher on what to do with these related rates problems. So, oh, did I talk about this? Oh, yeah, because I made a joke about read the problem carefully. That was stupid, right?
You did talk about it.
Yeah, I did talk about it. So, but it's good to just kind of go through this again. Remember, what we do here is we read the problem, we figure out what's going on. Second thing is we draw a diagram. You guys good? We draw a diagram. Make sure that you can draw some sort of diagram to wrap your brains around it a little bit better.
Okay.
So third thing, introduce notation. Figure out what you know, what you don't know. Introduce variables if you got to call things x or y or whatever, z. Assign symbols to all quantities that are functions, and 3 and 4 tie together. Express the given information and the required rate in terms of derivatives. Calculate your dv dt, calculate your dr dt, calculate your dh dt, whatever it may be, dx dt, dy dt, whatever. Remember that everything is in terms of time. All of these problems are going to be something happening over time. So we are only calculating the derivative in terms of time. So we're going to have to do a lot of chain rule, right? Write an equation that relates the quantities of the problem. Some sort of, maybe it's a geometric equation. Maybe it's a more algebraic equation. Not sure how it relates, but relate all of the variables together in one equation. Then use the chain rule to differentiate, and then solve, basically. Substitute the information to solve for the unknown rate. All right, let's take a look at this last one here. A man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man as he walks. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? So what we're really asking here is, what is the rate of change of the angle, right? There it is. We're really asking, what is the rate of change of the angle? I've got this guy, and the searchlight is rotating with him, right? And we're saying, at what rate is the searchlight rotating? So if, based on this diagram here, what I'm really trying to calculate is d theta dt, right? That's really what I'm asked to find. What is d theta dt? That's what we want to know. How fast is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? Okay, so basically from this diagram, they're calling it x. We want to know when this is happening, when x is 15. But we're also told that the man is walking along a straight path at a speed of 4 feet per second. What do you think I'm going to call that 4 feet per second? What notation do you think I'm going to use? Because he's walking on this path, right? dx dt. So dx dt is going to be 4. And we have our 20 being our searchlight, the length from his path to the searchlight. I know our perspective is a little shifted here, but this is a right triangle inside here, notated by that right angle. Okay, so I think we have everything that we need to have. Knowing that this is a triangle here, a right triangle, we can relate theta. See, now am I going to use Pythagorean Theorem? Because that might be our instinct. If we see a right triangle, it might be our instinct to do Pythagorean Theorem. But if we try to do Pythagorean Theorem, we would say x squared plus 20 squared is equal to z squared if z is our hypotenuse. However, I need to have something in terms of theta, right? Is theta, does theta exist in my Pythagorean Theorem? No. So I can't use Pythagorean Theorem here. So what type of equation could I use that relates theta, this side, and this side? Tangent. Tangent theta is equal to the opposite over adjacent, x over 20. Now, for us to easily differentiate, I'm just going to multiply the 20 over to the other side. 20 times tangent theta is equal to x. And now we will differentiate. Okay, differentiate both sides. What is the derivative of tangent? What is the derivative of tangent? I believe is it secant squared? You guys verify that for me. Secant squared. Yep, tangent is secant squared. So 20 secant squared theta. Do I need to use any sort of chain rule here? Yes, because remember, am I differentiating in terms of theta? Yeah. No, I'm differentiating in terms of time, right? D theta dt, right? So I'm saying this is 20 secant squared theta d theta dt. That's a time symbol, right? 20 secant squared theta d theta dt is equal to, and now on the other side, do I have to use any chain rule on the other side? Well, what is the derivative on x? Just 1, right? So it would be like 1 dx dt. So we're just going to say dx dt. You know, if we were writing it in terms of our prime notation, we would say 20 secant squared theta, theta prime, is equal to x prime. That's how we would write it. But remember, we're using this Leibniz notation to remind ourselves, A, that we are always differentiating in terms of time, and that it is a rate, right? It is a rate. When we see a fraction, we normally think of a rate. This is the rate at which theta is changing. This is the rate at which x is changing. Okay, I think we have all of our information. Let's plug in all of our information. We've got 20 times secant squared, oops, my c. My secant squared, oh shoot, what's theta? I have to have theta, don't I? Yes. I have to have theta. Right? Hold on a second. Yeah, I have to have theta. I have to know what theta is. Now, the nice thing is I can calculate what theta is going to be when x is 15. When x is 15. You know what? Because this is what's throwing me off a little bit. I'm leaving theta in here. And there's a reason why. Let's talk about that in a minute once we start solving this down a little bit more. I leave theta in there, and I'll show you why here in a sec. D theta dt is equal to 4. Because we'll be actually able to calculate what theta is with respect to what the trig ratio is here in a second. I'll show you. Okay, so what we have here, we just divide over to the other side 20 and secant squared. 20 secant squared theta. So d theta dt is equal to 4 divided by 20 secant squared theta. Just dividing that over to the other side. Because again, what we're solving for here is d theta dt. Now I'm going to reduce that down a little bit. 4 over 20 is 1 over 5. Right? So this is basically like saying d theta dt is 1/5 times 1 over secant squared. Why am I not writing my c's? Secant squared theta. Now, let me ask you something. What is secant squared? Or actually, let's go simpler. What is secant? 1 over what? 1 over cosine, right? So if this is 1 over secant squared, isn't that just like saying cosine squared? So d theta dt is equal to 1/5 times cosine of theta squared. Now, here's why I left theta back in there. Here's why I left theta in there. Because can we calculate what cosine of theta is? I don't actually even need to know what theta is, because I can calculate what cosine of theta is. Let's head back up to this picture here. Can I calculate what cosine is at the value when x is 15? Because that's the time that we're doing it at, when x is 15. Can I calculate what cosine is? Well, remember, cosine of theta is the adjacent divided by the hypotenuse. 20 over hypotenuse. Can we calculate what the hypotenuse is? Yeah, Pythagorean theorem. So x squared, or 15 squared, plus 20 squared is equal to, we'll call it, why am I calling it h? Let's go c. C squared. All right, so 15 squared plus 20 squared. Oh, that's 225 plus 400, so 625 is equal to c squared. I'm guessing that's like 25, but I'm going to double check. The square root of 625. Yeah, 25. So 25 is c. Okay, so cosine of theta is 20 over 25. Did I really even need to calculate what the angle actually was? No, I didn't need to do that because I can figure out what cosine of theta is. Okay, let's reduce that down a little bit. Cosine theta is divided by 5, 4 over 5. So cosine of theta is 4/5. Let's go back and plug that into our equation at the end. So that means that d theta dt is equal to 1/5 times 4/5 squared. One-fifth times 4/5 squared. 0.128. Good. That's exactly what I got here. 0.128. Now, if I'm calculating this at 0.128, that is, come on, you can come in. You come in. You can come in. Oh, I think it's locked. Do you want to come in for some calculus?
Oh, hells no.
Do you want to know what we're doing? This is a great problem. This is a really cool problem.
That gives me a headache just looking
This is
at
a really cool problem. You know what this is? So what we're doing here is we're calculating. There's this light on this guy,
Hold on,
right?
let me read this.
Okay. So we're calculating, this guy's walking this way at 4 feet per second, right? And this light is tracking him. We are calculating how fast the light is tracking him. Because it's fun. Because we can. Because we can.
Does the light go all the way around 360 degrees?
But the guy's walking in a straight line path.
What I'm saying is the
So
light.
he's not walking around the light.
I understand that. Why would you want to walk around the dang light?
I don't know.
I'm saying, is the light rotating as he's walking towards it? I'm walking towards this light. Is it doing this, or is it just blinking?
The light's not moving. It's just tracking him.
Wherever he moves.
Right.
Oh, and he's walking in a straight line.
Right. So like walk. This is the light.
What if he gives a little shimmy shake like that? Then what are you doing? Now you got to subtract and minus.
Right, I know. Then that becomes a whole different issue.
Subtract and minus.
That's it.
Which is actually a plus. Right?
Which is actually plus.
Am I getting it?
Yeah.
Bro.
Did you need some, or you just coming in the same house?
I wanted to make sure. You're doing calculus. You can't place an order correctly. Did you put it for 1105 or 1205? People, look here. He's teaching you guys how to track this light using sine, cosine, whatever the heck he's got up here. Ask him to place
I'm proud
order
of
at
him that
grinders.
he
Every Friday.
recognized sine and
Listen,
cosine.
every Friday we get grinders. I'm the driver. I'm the Uber. I'm the
Tape on his finger.
because I cut it.
I know. I've been asking this question for like 5 days.
All you got to do when you hit submit is tell them what time you want to pick it up. We've been friends for the last 8 years, 10 years. Every Friday, I get the order at 11:05. Every single Friday. We let him order the food one Friday. I get there, here for pickup. They just look at me. The lady's like, well, it's not ready. I said, it's always ready. I know. He puts 12:05. So now I got to wait an hour at Grinders.
If I could have told them 4:30,
I got to wait an hour at Grinders to get the food. I get back, we have 2 minutes to eat. Then I have heartburn the rest of the day. And he's trying to teach you how to track a light.
Not trying to. I'm doing it.
No, you're trying.
I'm sorry I interrupted. I hope you figure out what this light's doing to this.
You know, this is all recorded.
Oh, I can't go back and listen to this.
Yeah, this is a great one to watch. We'll watch this one back. We'll watch the game tape on this one. You have a great day. Okay.
Everybody have a great weekend. Enjoy your family and friends. Be safe.
Thank you. Thanks.
Okay, so this is 0.128. Where I was going with this was I really just need to figure out what the label is. 0.128. Because it's something per second, right? 0.128 something per second. Now, what do you think the label is going to be? If I'm rotating at an angle, what do you think the label is going to be? But if I'm going to use sine, cosine, and tangent, what do you think it's going to be? Radians per second. This is actually rads per second. Radian per second. What's that?
How did you get 4/5?
How did I get 4/5? Because that was a little tricky. I went back to the original problem, and because this is a right triangle, and I know that this is going to happen at 15, I calculate the hypotenuse when this is 20 and 15 to be 25. That's just Pythagorean, right? So if I want to know what cosine is, because this is cosine theta here, right? If I want to know what cosine is, I just calculate it in terms of this triangle that I created. Cosine theta is adjacent over hypotenuse, so 20 over 25, which produces gun in 4/5. Yeah. Okay, questions about that? Okay, let's stop the video now. Let's stop the video.